Hi guys. So today we're going to talk about solubility. So solubility is the ability to dissolve something into something else. So it's the dissolving process. We can dissolve solids into liquids and we can dissolve gases into liquids. So I'm going to talk about both of those. We're going to start with solids. In a solution, so when you dissolve things together, you get a solution. And in a solution, you always have a solute plus a solvent. So in a circumstance where you're dissolving a solid into a liquid, the solid is considered the solute. That's the one being dissolved. And the solvent is the one doing the dissolving. So that's water. When I say doing the dissolving, I mean the water because it's polar, right? We learned that in other notes. The water, because it's polar, is pulling the solid apart. Therefore, the water is doing the dissolving and the solid is actually being dissolved. There is a point at which you have maximum solubility. So as you add more and more solid, the water's ability to dissolve all that solid lessens because the water molecules start to get taken up, right? If each water molecule is pulling apart each solid, eventually you get like more solid molecules than there are water molecules to pull them apart. So you reach this point at which you can't dissolve any more solid. We look at that on this chart. So you can see this chart here. All these lines indicate a series of infinite points. So those points occur at specific spots. So if I can find one like right on the line, like here for KNO3 at 60 degrees Celsius, I can dissolve almost probably like 101 grams of KNO3. That means if I have like 110, I'm going to have some of my mass left there in like the bottom of the beaker because all the water wouldn't have been able to dissolve it. That is something we call supersaturated. So that's D here above the limit is supersaturated. So the line is the limit. If you're above it, if I give you a point, I say like at 50 degrees Celsius and 130 grams of KNO3, like how much will dissolve? You could say 80. 80 will dissolve because we can't dissolve all 130. Some of it won't. So the line indicates the maximum amount that can be dissolved. If I give you a point that's underneath the line, then that's what we consider unsaturated. So that's B, below the limit, unsaturated. And then saturated is directly on the line. So supersaturated is above, unsaturated is below, saturated exactly is anywhere on the line. We call it a direct proportion. As your temperature goes up, so does your solubility for a solid. So as we raise the temperature, we can usually dissolve more and more solid. That's just because the water particles are moving faster, so they can dissolve more molecules. It is opposite for gases. Gases, you can see all the curves are kind of sloped down. If you go back to here, these curves are kind of sloped up for the solids. For the gases, they all sort of slope down. You can dissolve a gas in a solvent. So specifically, let's use carbon dioxide as an example. You can dissolve carbon dioxide in water. We do it all the time in sugar water, in soda. But the gases dissolve kind of opposite of a solid. As you get colder and colder, you can dissolve more and more solid or more and more gas. So that's why we keep like soda in the fridge. If you open a can of soda and you keep it in the fridge, that carbonation will stay in the soda longer because it's colder. If you leave it out on the counter, it goes flat because the water is heating up. It's coming closer to room temperature, therefore it can't dissolve as much gas. So if you can kind of think of the soda example to help you remember this, at cold temperatures, we dissolve more gas. This is an inverse relationship. So again, as the temperature increases, the solubility goes down. Here, direct relationship, as the temperature increases, the solubility goes up. So in gas is an inverse relationship, and then a solid is a direct relationship. I'm only going to ask you to read the graph. You're going to be given a bunch of questions and asked to read the graph. There are examples in your notebook, so go ahead and take a look at that when you're ready. And that's it. Please let me know if you guys have any questions.